Okay. Good afternoon. This is the last lecture of Digitalization and Sustainability this year. And we close with a guest lecture from TrailOpeners. So we are very grateful that Ville from Finland, hi, is, is accepted to invest time to share their experience with respect to digitalization and some sustainability part. And so he will make the presentation. I will share after the lecture this afternoon also his material. And then I hear that you have also some time also left for questions in the end, right? Yes,
Yeah,
fantastic.
for sure.
Yes, so the floor is yours. So take all notes for the questions, and then when it's finished, we have a Q&A. Thank you.
Yeah, great. It's my pleasure to be here. Good afternoon, everyone. And welcome to listen TrailOpeners' journey and style of thinking, how sustainability in digital services should be taken care of. I'll first share a few facts about me and the company, but very well concentrate on the approach and experiences most of the time. And as said, there will be also time for questions after the presentation. I worked in digital business almost 20 years. I started as a developer, and I have also done some architectural work, program and project management, and now over 10 years of business management and development. I am a member of ISO standardization group in green software, and I'm also happy to be honored of Green Software Foundation's Green Software Champion title. I have had several board member positions, and currently I'm in Code from Finland Association as a board member. And off work, me likes to do trail running, as you can see from the picture. All right, so what's TrailOpeners? I'm sure nobody of you have heard about us before, but now it's the time. So we are the leading green software consultancy in the Nordics. We don't have any specific domains where we concentrate in, but we help our customers to go green what comes to the digital environments. We belong to the ecosystem of 8 companies, and we all share same business model, which is something pretty extraordinary. 80% of our companies are owned by our employees. So we have very committed employees who are thrilled to seek solutions for our customers' business problems. We aim to provide organizational solutions to our customers, not just optimizing 1 or 2 parts of the digital environment. We concentrate on processes, methods, and of course, software too. We help our customers by training them, measuring energy consumption from their environments and optimizing them. We also do a lot of architectural and implementation work with green software methods. So we help our customers to build their services and products too. We have several organizations and products we work with. For example, Green Software Foundation. We are just about to launch GSF Finland meetups. We work with universities like you, and of course our cooperation companies. In short, we built our entire business around making digital business greener. So what is the hidden footprint of digital services? You might have already heard, but globally ICT is projected to consume from 20 to even 50% of whole world's energy in 2030. It's quite a dramatical rise in consumption, and the generative AI is increasing the estimates all the time. This will lead to the situation that all old, already decommissioned fossil fuel power plants have been designed to run up again to power the need of the ICT domain. ICT domain is already producing more carbon emissions than global aviation industry. The exact amount varies in studies, but these are for conservative estimates. There are yet no regulation or standard way to measure the energy consumption in digital services. We in TrailOpeners are in forerunners in this field and are part of the national and global standardization groups of green software. We are also taking part to National Green ICT Research Program called Visiri, and that's located in Finland. Happily, regulators are, however, waking up. The CSRD directive is often seen as a reporting exercise, but the true story behind it is quite different. It is actually originated from the finance sector when they realized that companies need to be pushed towards better transparency and actions in climate crisis. All right, so what are the trends accelerating growing consumption of energy in ICT? In the last decade, size of the websites have been increased 3 times the size they used to be. Companies are planning also their end device life cycles within the recommendations from device manufacturers. For example, laptops 3 years and mobile phones 2 years. Devices usually tend to last much longer, and even 6 months more to the usage age decreases the emissions significantly. Mobile networks, they take up hugely more power, the data transfer, than optic fiber and other old solutions. More and more games and apps and so forth are funded with advertising. Advertising network is already consuming 10% of the whole internet's energy consumption. And of course, the generative AI is the largest trend at the moment, changing ICT domains pollution numbers in the totally wrong direction. Generative AI boom is spreading, and it's used for a bunch of fun activities among the right and wise usage. There is also a cascading effect. The more operations or data we need, the more hardware, network, and the premises are needed. This leads to growth of both operational, so runtime, and embodied, so manufacturing, energy consumption, and emissions. And as said earlier, you can do much also in the field of generative AI usage. Generative AI is exploding, and there are several consequences of it. In the USA, they are opening already closed fossil power plants to power generative AI and data centers. Energy consumption of digital services is rising so fast that green energy producement can't match it. So the gap between ICT energy consumption and those provided with green energy is wider all the time. Thus, the only reasonable thing to do is to cut energy usage of digital services. So, how much is the generative AI actually using energy? OpenAI's leadership recently said per prompt figures suggesting average ChatGPT request uses about 0.34 watt-hours of electricity and very, very low amount of water, like a 1/15 of teaspoon. Those numbers grabbed attention, but arrived without a transparent method and focus on inference only, not including training. Independent observers flagged the lack of peer review and the risk of undercounting the full system. Meanwhile, other analyses so complex prompts can consume materially more energy, as you can see from the picture. The point isn't to litigate one number, it's that methodology matters. Next, Google's 2025 environmental report said that electricity demand for its data centers rose approximately 27% year over year, while it reports a 12% drop in data center energy emissions thanks to procurement and efficiency. At the same time, Google published per prompt figures for Gemini, and it was something about 0.24 watt hours and very little amount of water for the median text prompt. Critics highlight those holes. They were heavy reliance on market-based accounting that can understate real-world impact versus location-based. The use of medians that can hide outliers and partial water boundaries that may exclude power sector water. And also Google's overall emissions have risen almost 51% since 2019, underscoring how demand growth can outrun efficiency. So the translation is that transparency is improving, but key gaps remain. When you step back to the system outlook, the EIA project data center electricity consumption could be roughly double by 2030, with AI as a major driver. As usage scales, the gravity moves from one-off training spikes to the everyday inference load. Leaders and all you need planning assumptions that match growth, not hopeful averages of some prompts. So what should we demand then? Standardized audit reporting across training and inference, energy, carbon, and water usage. Maybe some percentiles, not just medians, and clear scope of boundaries. Vendor transparency clauses in contracts also. Only by demanding more we get the real picture from the big players. And optimism is not a substitute for numbers. And of course, our position at TrailOpeners is simple. We don't say don't use AI. We say plan your AI strategy, architecture, and usage, including railguards and ethics, so people can adapt Gen AI smartly and energy efficiently. Set compute and carbon budgets, right size and cache, batch inference, choose regions and times with cleaner grids, and publish emissions per prompt next to latency and costs. You can do AI with eyes open, methods disclosed, and efficiency by design. All right, this picture comes from the Green Software Foundation. These are the fundamental principles to more sustainable services. So it said that green software is an emerging discipline that at the intersection of climate science, software design, electricity markets, hardware, and data center design. Green software is carbon efficient software, meaning it emits the least carbon possible. Only 3 activities reduce the carbon emissions of software: energy efficiency, carbon awareness, and hardware efficiency. So what comes to the energy efficiency, you should always consider how can you produce your tasks within digital services by using as low amount of energy as possible, whether it's algorithms, CI/CD pipelines, or choosing a coding language. In cloud, you can think of PUE as a multiplier to your application's energy consumption. So for example, in your application, if your application consumed 10 kilowatt hours and the PUE of the data center is 1.5, then the actual consumption from the grid is 15 kilowatt hours. So 5 kilowatt hours goes towards the operational overhead of the data center, and 10 kilowatt hours goes to the servers that are running your applications. So hardware efficiency, the hardware used in the process of creating your software is an important element to consider for a green software practitioner. You will see how embodied carbon is a hidden cost when it comes to hardware and the different measures you can take to reduce the impact that the creation, destruction, and running of this hardware involves. For example, extending its lifetime or switching to cloud servers. Think serverless and event-driven architectures, for example. And the carbon awareness. Being carbon aware means responding to shifts in carbon intensity by increasing or decreasing your demand. If your work allows you to be flexible with when and where you run workloads, you can shift accordingly, consuming electricity when the carbon intensity is lower and pausing production when it is higher. For example, training a machine learning model at a different time or region with much lower carbon intensity. So this is our approach and message to organization working with digital services. We claim that this topic considers all people working in digital dependent of the role. Directors are ought to update their management knowledge and systems to include sustainability also in digital services. Especially in this current economical situation, there are usually claims that sustainability is an extra cost. In digital world, you can always say that this is only making services with quality and efficiency. This is nothing which is glued over digital development, but this should be an important aspect and principle of digital development. In the 1990s, resource usage was a different thing. Computers were no fast, there were no cloud resources, and everything was pretty pricey. This situation has changed, and almost every resource is available from cloud, and they are not costing much. This has led to the situation that teams and developers in general do not think how they should optimize resource usage. Good example is libraries. There are plenty of examples in code how developer has taken the first library mentioned in the internet to use in his software, although the whole problem might have been more easier and maybe even more faster to solve with a couple of lines of code by themselves. There are 5 key principles to follow in green architectures. 1, energy efficiency. Ensure that the software uses as little energy as possible during operation, as mentioned earlier. 2, resource optimization. Use computing resources effectively to reduce or avoid waste. This includes optimal usage of server resources, efficient network usage, and optimized end-user usage. 3, sustainable development practices. Adopt methodologies that promote sustainability, which can reduce unnecessary rework and resource consumption. 4, lifecycle management. Consider the environmental impact of software from development through disposal. This includes sustainable coding, regular updates to improve efficiency, and consideration of recycling or reusing software at the end of its life. And 5th, cloud and virtualization. Use cloud resources and virtualization to reduce need of physical hardware, but do it wisely. All right, then some data from academic research. There are plenty of studies which says that correct optimization can reduce energy consumption And in average, it's 40% on the server side and 20% on the client side. And of course, time shifting in data-heavy operations can significantly reduce operational costs too. Our message is also that you should think how easy or tricky it is to make these alters or use green software practices. The low-hanging fruits are pretty easy and they make big impact with really low level of costs. But as you get deeper and deeper into green software, the more trickier the things will come and they will cost more. So you should always also keep in mind how tricky is the task you are doing and what's the reward of investing some amount of money for making it green. Okay, what are the experiences from customer meetings? The picture pretty much says it all. When I walk into customer meetings, I often hear the same line, said with a friendly smile, digital emissions, not on our priority list. We are focused on the big stuff. And I get it, I truly get it. The smokestacks and supply chains feel tangible, code and cloud don't. But take another look at this picture. A high-profile executive tossing sustainability scope 3 and climate targets into the bin, dollar signs in his eyes, while CO2 curves climb and planet burns outside the window. Okay, maybe that's a bit surrealistic. And it's provocative on purpose, because that's what happens when we treat digital as invisible. Here's what we see in boardrooms again and again. Sustainability goals on one slide, an AI roadmap on the next. Full speed ahead, pilots everywhere, no guardrails, no plan for energy, no thought for where the compute runs or when. The ambition is real, the oversight is too. Then the conversation shifts. Because when we talk about green software, we are not just talking about polar bears or some greening actions. We are talking about performance, reliability, and costs. Right-sizing cloud and killing idle resources cuts spend and carbon. Pruning unused features and heavy polling makes apps faster and lighter. Smarter data life cycles collect less, store colder, move smarter, reduces risks and bills. AI with an efficiency plan, model right-sizing, caching, batching, carbon-aware scheduling, delivers value without runaway compute. That's when heads start nodding, because efficiency is a language every CFO and CTO already speaks. But let's be clear, this isn't about adding a green sticker to your backlog. It's about bringing digital into the same management system as the rest of your climate strategy. Your customers use your apps, stream your media, call your APIs, prompt your models. That energy belongs into the picture. If we don't illuminate the digital part of emissions, the math won't reach the targets, no matter how clean your data center power purchase is. Efficient systems are good business. Clean code is fast code. Carbon aware is cost aware. If digital is a meaningful part of your revenue, it's a meaningful part of your footprint and your opportunity. Let's pull those papers out of the bin, put real numbers on the screen, and make the curve outside that window bend the right way. I noticed that I'm a bit late, but I only have 2 slides left, so just a moment. These are some tangible and simple examples on what we've done with our clients. There are some results presented. We have also managed to produce some real-life business cases. For example, Betolar, which is Finnish stock company, published a press release before summer holidays. They had managed to cut emissions of digital environment over 50% and cut costs around 30%. And of course, we were involved in this case. My message to you is that it's essential to show these results, especially with numbers. CXOs and executives do not buy sustainability. They buy concrete business results. And it's also your job to sell these methodology things wherever are you working with digital services. Base your claims with numbers. They are available. And of course, we have noticed also that old wisdom is you get what you measure. That is true in this case also. Organizations should show energy consumption and emission numbers to digital development teams and developers. By understanding and setting concrete target and goals, software will become green sooner. So digital services can be sustainable. You just have to make it. Thank you.